Okay, so we have discussed a lot of things related to the counting principle and everything else. So now we'll start with the permutation and combinations, and this is the most important chapter and most important topics because a lot of questions are being framed from the permutation and combinations. So like if you just walk every year, a lot of questions are actually asked using the permutation and combinations, and using the permutation and combinations, a lot of different probabilities questions are also framed. So questions from probabilities are also be there, and reasoning type questions are also framed using the permutation and combinations. So we will see like obviously we have seen some topics on the permutation and combinations, which is the like those fundamental of counting techniques. So counting techniques also comes under the permutation and combinations, like the product rule and the sum rule. Those things are also the part of permutation and combinations. Okay, so we'll see some more things related to the permutation and combinations, and then we'll see some questions. Okay. So, like before studying the permutation combination, the most important part is running about the factorial. So, what is the factorial? Okay, so let's learn about the factorial first. Okay, so like factorial is written as n factorial. It is defined as the product of n natural number starting from 1. So, it's 1 into 2 into 3 into dot 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 into n. Let's say we're defining 5 factorial. It means that 1 into 2 into 3 into 4 into 5. Obviously, for defining, let's say a 10 factorial, you can either start from 1 into 2 into dot dot, or you can also start from 10 into 9 into 8 into dot 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 3 into 2 into 1. Anything is going to give the same value. So it means that 5 factorial is going to be 5 4 is 20, means it is going to be 120. If the 3 factorial you are trying to find, it is going to be 6. 2 factorial you are trying to find, it is going to be 4, and something like that. So obviously the main fundamental things about the permutation combination is the factorial. In the notation you will see the factorial. So simple thing about the factorial is that it is defined as the product of first n natural number. Obviously, 0 factorial is defined as 1, and 1 factorial is also defined as 1. So this is a by default the notation of 0 factorial and 1 factorial. Okay, so this thing is going to be there. Okay, now let's see some problems to the factorial part. Obviously, this is the basic definition of factorial, but obviously we can see the some problem. So for permutation combinations, you can solve RD Sharma book, complete book you can solve. Obviously, if you don't want to solve the exercise, just don't solve the exercise, just solve only the basic illustration. Solved illustration you can solve, solved example, and that is also be enough. The question is an is defined as n into n factorial. There is something called an, means an is defined as in the sequence defined as n into n factorial, means a1 is equal to a1 means 1 factorial into 1 factorial. Okay, 1 into 1 factorial. A2 means 2 into 2 factorial. A3 means 3 into 3 factorial, something like that. Okay, and we are trying to find summation of all such r, all such a from 1 to 100. So means summation r is equal to 1 to 100 AR. It means that A1 plus A2 plus dot 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 plus AR. Okay, and AN is in general defined as n into n factorial. So obviously, we want to find this particular part. Obviously, this particular part is actually broken down into R into R factor. This is the definition. Obviously, R you can write as R plus 1 minus 1. Obviously, R can be written as R is equal to R plus 1 minus 1. This is just as R. So what is the benefits it's give you? Just we will see. So R is written as R plus 1 minus 1. If you just multiply the both the part, this will be R plus 1 into R factorial. So like I told you, this factorial thing is something like I told you, if you're trying to define a 5 factorial, it is 5 into 4 into 3 into 1. So if you multiply 6 into 5 factorial, it is going to be 6 factorial. Why? Because 6 factorial is equal to 6 into 5 into 4 into 3 into 2 into 1. So obviously, if you multiply 6 into 5 factorial, it is going to be 6 factorial. So if you're going to multiply r plus 1 into r factorial, it is going to be r plus 1 factorial. Okay, so this thing we have. Okay, so we are multiplying r into r plus 1. So this thing will be r plus 1 factorial, and this thing will be minus 1 multiply this thing will be r factorial. So what the benefit it will give you? Now if you just expand everything by putting value of 1, so you put 1 here, you get 2 into 1 factorial, then 3 into 2 factorial plus 4 minus 4 factorial minus 3 factorial dot dot. So everything will start cancelling. This will get cancelled by this way, this will cancel by this way, and something like that get cancelled. And in the end, only this will also get cancelled. Only 101 factorial is left minus 1. Okay, so this is the right answer for your question. This is how actually you work with the factorial. Okay, let's now move with some other example. I think this is getting. Okay, so let's now move with some other example. So the other example is all about. Let's say you have a three numbers. Okay, that three number is n factorial, 3 into n factorial, and n plus 1 factorial. And these are in GP. So like in GP actually means that like if some number is GP. Let's say A B C is in GP, then it means that B is equal to under root AC. Okay, or you can say that B square is equal to AC. Okay, so this particular fundamental you can get it from the here part. So I've just included some basic definition of GP and AP. So obviously you can follow this part to cover your AP GP thing, but obviously you can see that. So how to solve this example? So it's saying that n factorial is equal to n, this particular three numbers are in GP, means B square is equal to AC, means 3 into n ka whole square is equal to A, means first term into C. So if three term A, B and C are in the GP, so B square is equal to AC. This is in the, if in GP, this is in the AC. This is implied by default. Okay, so this thing you can follow. Okay, now let's see how you can solve this particular question using this particular formula. Okay, so it's saying that 3 into n square, just to you just calculate this square, it will be 9 into n factorial ka square, and this will be n factorial into n plus 1 factorial. Obviously n plus 1 factorial you can break as uh, n factorial into n plus 1. Okay. In general it is true. Let's say 7 factorial is there. You can break as 7 into 6 factorial. This is true in general. You can do it for anyone. Okay. Obviously 7 into 6 into 5 into 4 into 3 into 2 into 1. This is there. But obviously this is just the 6 factorial. So 7 into 6 factorial is 7 factorial. 100,000 means 1000 factorial you want to break. Break into 1000 into 99999 factorial. Okay. So this thing is there. Okay. So what do you need to do? Break this part and then you multiply all the things. You can say that this n factorial is get cancelled with the n factorial, and then you get n is plus 1 is equal to 9, which is n is equal to 8. So what is asking, if this particular thing is, this term are going to be in which term? Okay, so just to find n factorial and then 5 into n factorial and then n plus 1 factorial. So these things are just the n factorial is 8 factorial, 5 into n factorial is equal to 5 into 8 factorial, and n plus 1 factorial is equal to 9 factorial. So obviously if you just like let's say there are three terms A, B, C, and these things are in GP, then the particular thing is C is equal to uh, means if A, B, and C are in the GP, then the means this the sum of the particular two terms means B is equal to going to be A plus C by 2. Okay, sorry, A plus C by 2. So B plus B is going to be A plus C by 2. Okay, so these are the just fundamentals of AP, GP, and HP, and you can utilize those things to solve the factorial questions. Okay, so here we get that this particular thing is going to be two times this particular thing is going to be 10 into 8 factorial, which is n into n plus 1 factorial. Okay, so these thing obviously you can see that. Okay, so obviously you solve this particular part, and then you can see that these things are in the AP itself. So whatever this thing, just to find those part and see whether they are in AP, GP, and HP by looking at this particular part. Okay, if A, B, C are in GP, then B is going to be A plus C by 2. Then this particular thing is going to be A plus C by 2. Okay, so yeah, these are some questions related to the APGP. But now let's now see the application of the factorial. Okay, what are the application of factorial? Okay, so like let's say we have a p as a prime number. P is a prime number, and n is a positive integer. N is a positive integer. Okay, so p is a prime number and n is a positive integer. Then what is it? It is saying that let EPN, means EPN denote the exponent of power p, exponent of prime p in the positive integer n. So like let's say 3 factorial talking about, it is going to be 6. So 2 to the power 1 and 3 to the power 1. Let's say 4 factorial talking about, it is going to be 24. It means that 2 to the power 2, then 3, obviously 2 to the power 3 into 3 to the power 1. Okay. So these are the prime numbers, prime factorial. So you can see that these part means we obviously in 4 factorial we have some power of p. P means if we want to find the power of 2, we have something. Okay, it is 3. Okay, so EPN denotes the exponent of power p, prime p in the positive integer n. Then then EPN factorial is equal to, means EPN factorial का मतलब है कि what is the power of prime p in the n factorial. Okay, what is the power of prime p in the n factorial? So let's say 100 factorial may you are trying to find out what is the power of 7. You can find out. So what is the formula for that? It is n by p. Okay, it is n by p, then n by p square. This is the greatest integer function. Obviously, we are talking about the integer. Then n by p cube. Okay, then n by ps. So whether it will go till we find such a s that if you do p to the power s, it is going to be less than equal to n, but obviously p to the power s plus 1 is equal to greater than n. So let me just explain it with the example and then you'll understand it better. Okay. So it is saying that find the exponent of 3 in the 100 factorial. Now what do you need to do? 100 by 3 need to do. Okay, 100 by 3, then 100 by plus 100 by 3 square, then plus 100 by 3 cube, 3 cube, then plus 100 by 3 to the power 4. So this thing is going to be 27 point something, obviously 33 point something. So this is 33. Obviously we need to take the integer because this trumps the greatest integer function takes the integer. 900 by 9 is going to take the 11. Okay, this is 27 by 100 is going to take the 3. So obviously we have divide 100 by 27. You will get something related to 3 point something. So only take the integer part. And now 100 by 3 to the power, which is 81, means if you divide 100 by 81, you will give the something related to 1 point something, which is 1. Now we don't take more power of 3 to the power 3 to the power something, because if you take 3 to the power 5, it is going to be 243. Okay, 243, and obviously this particular number is greater than 100. So obviously we take all those powers which are less than 100, less than the number that we are trying to find out. Here we're trying to find out the factorial of 100. So basically if you add the all number, you will get 48, which is actually going to be the number of exponent of power in 3, exponent of 3 in the 100 factorial. So what is the exponent of 3 in the 100 factorial? If you do 100 factorial, whatever the number going to come, the 3 factorial का जो power होगा, it is going to be, sorry 3 not, 11 to n minus 1 2 also, or maybe let's see 11, it means choosing 100 11 different things out of 100. So these are the choosing, not the selecting, not the arranging. Okay, let's see some example. So it is required to sit 7 men and 3 women in a row. So there are 7 men, 7 आदमी हैं, 3 women. They are occupied to sit in a row, and the women occupy the even places. So let's say there are 10 chair. Okay, एक दो तीन चार पाँच छः सात आठ नौ दस, 10 chair are there, and obviously it asks that women should sit at even places. So what is the even place? This is a even place. This is the one. This is second. This is the even place. Four. This is six, 8, and this is 10. These are the even places. So out of 5 different possible places, you have to choose 3 women. Obviously, there are 3 women, 3 women. Okay, and obviously women should choose at seat at the three places, means obviously even places. So how many places of even you have five places. Okay, so you have choose three places out of them. You choose three places. So let's say, oh, woman one is sitting here, maybe woman two is sitting here, maybe three is sitting here, or something like that. Maybe someone is here, someone is there. But obviously, if you have three women, obviously you can choose any five, any three object, any three places out of five, and select and keep women there. But obviously, it may happen that out of those three places, three women can be select differently. Let's say woman one, two, three is here. Obviously, it may happen that woman two is there, woman three is there, but woman one is here. Maybe or happens that woman three is want to sit here, woman two is here, but woman one is here. So how many total possible arrangement are there? Total possible arrangement is three factorial. Why? Because three women, obviously you choose five out of five. You choose the three seat. Five even seat are there. You have to choose the three seat. These are even. So obviously choosing those three seat, you can arrange each and every woman in the three factorial ways. Now, what about the main? Okay, men are also there now. You have to think about them also. So what about them? It means that out of means obviously out of 10 places, five had been chosen. Means out of five even three has been chosen by women. Now seven places left. So just choose seven by seven. Obviously you can choose seven out of seven for any person, and then multiply by seven factorial. Why seven factorial? Because those seven-person should be sitting among them. Maybe it happens that male M1 is here, M2 is here, someone is here. Maybe M2 start to be first, M1 is different or something like that. So these type of things can also be possible in the permutation combination. So total number of ways is 5 factorial into 3 factorial to choosing the women and then arranging them, then choosing the men and then arranging them and multiply total to get the overall result. So this is also example of product rule that we saw earlier. Product rule, just number of ways to doing sitting men and then the number of ways to sitting women, obviously women and the men, and then multiply those two parts to get the product rule. Okay, so this thing is there. You can also read this part from the RD Sharma book also. You can solve a lot of different questions. Some more examples, nothing defensive. Some more examples are there. So let's see how we can see some more examples. Okay. So the first example is how many signals can be made out of five flag from eight flag of different color. So total there are eight flag of different color, and saying that how many different signals of five flag. So obviously choose five flag from those eight different color, and obviously you can arrange five flag. Let's say there is a red flag, blue flag, green flag, orange flag, and some other flag. So obviously you can arrange those flag into somewhat different order. Maybe blue first, red after, orange first, green after, something like that. So you can arrange them using the five factorial way. So total number thing is 8C5 into 5 factorial. Okay, so this is the actually way you can find the number thing. Obviously, you can solve the same questions using this thing. So it's taking that how many different signals can be made using the any number of flag from six flag. Any number of flag means either it can be one flag or two flag or three flag or four flag or five flag or six flag. So out of the six flag, it can choose any number of flag. So obviously, like if it is 6CR into R factorial. Why this thing? Because let's say we are talking about the first five flag. Obviously, 8C5 into 5 factorial out of 8 flag. So we need to do this 6CR into R factorial, means choosing R factorial at a time, R flag at a time, and then arranging them using the R factorial, and then obviously summing them using the summation. So obviously sum from R1 to 6, and you can get the result. Obviously, you can solve those part using the result that you have, get the result. Obviously, there are a lot of different type of questions based on permutation and combination. I keep changing the C, R, and things, and you can start solving a lot of questions. But obviously, solving the RD Sarma is advised for this particular part. Now, the thing is, how many different words of each containing two vowels? So, two vowels is there. Okay, three consonant is there, and can be formed with five vowels and seven consonant. So they are saying that you have five vowel, and you have 17 consonant. These are given to you, and you have to form different words, each containing means those words would contain two vowel, means two vowel V1 V2, and three consonants C1 C2 C3. Obviously, order can be different. So obviously, how to do those things? Obviously, out of five vowels, select two vowels. Okay, and out of those 17 consonants, select three consonants. Obviously, you can choose two vowels by this way, and choose three consonants by this way. Using product rule, multiply those two way to get all the such word. Okay, and obviously now when you have choose this vowel, you have to arrange them also, like in the order they can arrange them. Obviously, V1 V2 V1 C1 C2 C3 can be there. Obviously, B1 C1 V2 C3 C1 can also be there. Some different arrangement can also be there. So after choosing all those part, we also need to multiply it by 5 factorial to get all such arrangement. Okay. So one, you need to do choose, and then you need to arrange those part. Okay. So these are the things that you need to follow. Okay, there are some more useful formula. This one of the most popular useful formula is, like sometime it makes us find the sum of the numbers found by n non-zero digit. Like find the sum of the numbers. Let's say if their digit has given 2, 3, 4, 5. So it asks it whatever the numbers you get, whatever. Let's say using 2, 3, 4, 5, a lot of numbers can be originated. So find the sum of all those numbers. So how we can do that? Simple formula, sum of the digits into n minus 1 factorial into 10 to the power n minus 1 upon 10 minus 1. So here example for you, sum of all the numbers that can be formed with the digits 2, 3, 4, 5 at a time. So what you need to do, sum of the all the digit, okay, and then 3 factorial n minus 1 factorial, because n is equal to 4 here, 4 number are there, 4 number are there, so n minus 1 factorial which is equal to 3 factorial, and then 10 to the power 4 minus 1 upon 10 minus 1. This is going to be your answer. These are just direct formula. Obviously proof is not something you should be concerned of, but obviously these are direct formula that you can use to solve MCQ type of questions. Okay, some more different types of questions are there for you. So one of the most popular type of questions is obviously a box containing two white and three black ball. Okay, so there's a box containing two white. The box has two white and three black ball and four red ball. Okay, so the number of ways in which three balls can be drawn from. So three, two white, red, three black, and four red balls are there. We need to find the number of ways three balls can be drawn from the box. At least one black ball is to be included in the drawer. So let's say we're drawing three balls, then at least one black ball, at least one black ball should be there. So let's say, like a total number of ball is 4, 3, 7 to 9. So 9 see three ways. You can draw three ball by 9 see three ways. But there you can also, it may happen that you are also drawing some balls which are not black, and is saying that you have to draw at least one black ball, at least one black ball you need to draw. So how you can do this particular thing, let me just explain it to you. Okay, so you can do this particular thing by this way. So what you need to do, one thing, okay, so you need to just forget about the black ball. Just now find what are the total number of ways from which you can draw only white and red ball. So there are total six, two black, two red, white ball, and four red ball. Total six ball are such that there are white and red, and they're not black. So if you draw three balls from those six balls, they are not going to be any red. And if you're going to subtract it 6c3, we means like this 9c3 contain all the balls. That is actually white ball, black ball, red ball. Some balls are not also black ball. It may happen that we're drawing from only white and black. So what you can do, just 9c3 and divide minus 6c3. And what is 6c3? 6c3 means all those balls which are either white and red ball. So obviously, if you just subtract all those balls which are either white or red ball, it will give all the list set of all those such draw where at least one black ball is there. Okay, so you can just read this particular part, and obviously I will explain this particular part why we are subtracting the 63 in this question. Obviously there are a lot of different questions there, but I think you can solve all the questions. Okay, you can just solve all the questions just by reading the fundamental thing. So like NPR and NCR, you have to understand the fundamental properties you need to understand, and obviously using all those things you can solve a lot of different questions. So here is that there are 10 points in a plane. So let's say there is a plane. Okay, this is a plane. There are 10 points. Okay, no three of which are in the same straight line. So it's maybe 2 points are in the same straight line, but no three of them are the same straight line. Okay, it's not there. Except 4 points which are collinear. Means there are 4 points which are going to be collinear. Okay. The number of straight lines obtained from the pair of these lines is, okay. It's saying that you are going to have some lines which are actually in the straight line. So 4 point others are going to be straight line. Okay, and as for number of straight line obtained from the pair of these points. So like a line is formed actually when you connect any two lines, any two dot, and connect them. So let's say you are having 10 dots, so choose any two dot. Okay, choose any two dot, connect them. Choose any two dot, connect them, you'll get a line. So 10c2 means they are all the possible number of lines there if all the points are different. Okay, now, the thing is that these four lines are collinear. What this means that one, two, three, four. So out of this four line, only means like these four lines are collinear. So it is not like if you can draw this line from this line you get a different line. Obviously these are in the same line. So what is saying, a number of straight line formed by joining 4 points taking two at a time. So these four line will actually have some common thing. These are just missing some point. Why? Obviously 10 to 2 means total 45 lines are such that if you just each and every point is not on the same line, it's not 3 point on the same line, not 3 point on the same line, then there would have 45 line possible. But it has given that 4 point are on the same line. So we have missed some point. Okay. So what we do, we try to find all those lines that is made with these four lines. Okay, 4 C2 means six lines are such that it is actually made by four lines. So let's say one, two, three, four. So one, this line, this line, this line, four line, and this six line. Six line are there that we are actually missing. But if because if it would not have been this 4 points collinear, we would have more six line. Okay, so we will decrease minus six line from this particular part. But obviously we have a single line. This particular single line is there, which is connecting all the points. So that will should be included. So that is the final answer to your question. Okay. So why we are subtracting 6? Because we are missing this 4 point because these are collinear. If it would not have been collinear, we would have 6 line. That's why we need to subtract this 6 from 45. Because 45 is the total number of line if the point is not collinear. So this within the simple explanation that the 4 points are collinear, we employ this information to do this. Okay. Now, there is something called permutation of all distinct. Permutation of all distinct means, let's say, the number of mutually distinguishable permutation of n taken all at a time. P are of alike of one kind and Q are alike of second kind. Let's say the total number of n element. Let's say P are boys and Q are girls. Okay, and your teacher is saying that okay, the total number of n student, and you need to what you can say, you need to these are the permutation thing. You need to arrange all those students such that maybe I'm not able to explain it in the example. We'll just see some examples. Okay, so what it is saying that, let's say you have total number of n element and you are trying to arrange those elements into means it's saying that there are number of mutually distinguishable permutation of n things taken all the time. P are alike of one kind, Q are alike of second kind, such that P plus Q is equal to n. So we need to find the permutation of n items. Obviously n P R is there, which is equal to n factorial upon R factorial, n minus R factorial. But now here the thing is that we have out of n element there are two group. One, there are element of p kind and there are element of q kind. So this, the number of permutation is going to be n factorial upon p factorial into upon q factorial. Okay, and if it's, let's say there are three kind r or a's, then it is going to be n factorial upon p factorial upon q factorial into r factorial into s factorial. So these things are always going to be there. Okay, so this either can be extended to r number of group or either can be extended to single group. So let's see the examples and then it will be more clear. Okay, so let's say we are trying to find the permutation of all the different words of 1 minute, 1 minute. Yeah, word Mississippi. So just forget about this example. Let's take there is a word take, T-A-K. Find all the permutation of the letters. So there are four what you can say, four letters in the particular word. Okay, this particular word, four letters, and we need to find 4p4 because taking four at a time, you need to find all the permutations. So it is going to be 4 factorial upon 4 minus 0 factorial, 4 minus 4 factorial, which is going to be 4 factorial, which is going to be 24. So 24 such words are there, which is actually be found using the take letters of the take. Means A, K, T, E. This is another word. K, A, T is the another word. E, A, T, K. So there are 24 possible words. So same thing we are also talking about here. We need to find the total number of, obviously like take word means all the letters are different, they're distinct word. But this Mississippi word is something in common, like s is the something that is belong to s, are four s are there. Okay, one, two, three, four eyes are there, and rest are the common. So earlier we thought that if there are n element, okay, and p are of a like of one kind and q are of some other kind, then total number of permutation is n factorial upon p factorial upon q factorial into q factorial. So here it is going to be 11 factorial because 11 words are there, and a's are four types of a's are there. So obviously we need to take it 4 factorial into 4 factorial for I part. So this is going to be your, obviously for distinct element you don't need to do something like m are distinct. Obviously p are also there. Oh, so we miss the p. So p is also there. There are two number of p. So it's going to be this 2 factorial also. Okay. So this is the real number of thing that you have. the number of such arrangement of Mississippi. So these are the things that you know to consider. If some words are repeating, then this is the way actually find the permutation. RD Sharma is the best book to practice. I already told. Let's say there is something called apple. Try to find all the arrangement of word in the apple. So basically, you know, like if it would have been everything is different, it would have been 5 factorial because we saw that if you do 5p5, you will get the 5 factorial. But obviously, there are two letters which are repeating p. So for that, we will divide it by 2 factorial. Let's say there's something called a p p l l e. So you can see that here p is also repeating two times, l is also repeating two times. So in the permutation of all the letters from this word, permutation of all the letters, or you can say that by arranging all the letters differently, you will get the 5 factorial upon 2 factorial into 2 factorial. Okay. So there are a lot of problem. This is also portable problem from the RD Sarma. You can go and practice this part. Okay. So you know, like there is a particular called dictionary problem that I think I should discuss with you because these things are the common. So it's saying that the letters of word Sachin. So there is a word Sachin. So the letters of word Sachins are arranged in all the possible way. Means A, C, H, I, N, H, I, N. Means everything. Means whatever the possible combination you can think of the word Sachin, it has been arranged. Now it is asking that these words are written out in a dictionary. So you know, like how in a dictionary things are written. Things are written alphabetically. Like A means starting from A, everything will be written. Obviously, starting from let's say we have three A, P, P, L, E. Okay. So in the dictionary, the first word will be A, E, L, P, P. Why? Because in the dictionary, A comes first, E comes after the A, L comes after the A. Means in the alphabetically, these things are arranged. What will be the second word? A, E, P, L, P. Why? Because obviously if you change these two keywords, it's going to be the same. But obviously, if you change these two words, it's going to be a different word. Okay. So something like that will be there in the dictionary. So it's saying that Sachin word is actually arranged in the dictionary. So what is the position of Sachin? What is the position of Sachin in the serial number? Okay. So you know, like let's arrange everything alphabetically. So we have A, then we have C in the alphabet, I, no, first H, then I, then N, then S. Okay. This thing is going to ACHINS. Okay. Now we can arrange this particular letter. Let's say we keep A as a fixed because this particular letter Sachin is starting with the S. Okay. Let A is a fixed, then all the five letters can be arranged by five permutation. Okay. Now let keep C as the fixed. Then again we have the more five factorial more words. Then keep H as the fixed, then I as the fixed, then N as the fixed. And for each we have five factorial more words. Okay, so these are the total words before we pick to the Sachin. So now we have S. So what will be the first word from the S? It will be S, A, C, H, I, N. So why it is that? Because alphabetically, if you just arrange all the keywords, then if you start with the S, then you have to arrange everything alphabetically. You have to arrange the all the letters alphabetically, and you can then know that in the alphabet, A comes the first, C comes the second, H comes the first, then comes I, then the N. The total number of word is all the summation plus one. So you know, like if the word have been S, A, C, H, N, I. Let's say this word has been there. So what will be the order of this word? So obviously in the alphabet, this particular word is going to be there. Then after it, the next word is going to be S, A, C, H, N, I. Because obviously I is the first in alphabetical order, but the next order will be what is the next in the alphabet. So this particular thing is going to come here, and this order will be changed. Okay. So you know, like these, I think this thing is clear. Obviously, you can read the solution to understand this part. But this is how you do that. Just find all the occurrence of keyword, and then from the letter from where it starts, start tracking each and every word. Obviously, it would have been S, A, C, N, I, H. Then you have to keep 4 to 5 word tracking. Whether then you have to reset that word. Add all the things. Add number of counter that you did it. Means number of tracking you did. Let's say you read we arrived at 13 by counting the 5 more words. Then that will be the there. So obviously there are a lot of examples there in the artisan book. I think it's clear, and obviously this thing will clear. We just do the more example. Then there's something called circular permutation. Let's say, you know, like in the tabular permutation and linear permutation, circular permutation are different. So, you know, like it is saying that the number of circular permutation of n distinct object is n minus 1 factorial. Okay. And linear is n factorial. Okay. So this thing you have to keep in mind. If you're doing the linear permutation, it is going to be n factorial, means arranging them in the single line. And if you are arranging them in the circle, this thing is going to be the n minus 1 factorial. So how the things are going to be there? Let's say 20 persons are invited for a party. The number of ways they and the host, means there is a host, okay, there is a host H which is invited everyone the party, 20%, P1 to P20. The number of ways the host be seated at a particular table if two particular persons sit on either side of the host. Okay, it's saying the number of ways they and the host be seated at a table. So total number of person are the 21 now. Okay, 21 now. If two particular person, let's say your host has two different spatial person, p1 and p2. Let's say for the sake of p1 and p2 are the spatial person. So p1 and p2 are saying, okay, we want to sit with h, we don't sit with other person. So means p1 want to sit with h and p2 also want to sit with h, means p1 and p2 will be side of the h. It's saying that thing with two particular persons sit on either side of the host, means one person sit this side and one person sit this side. So we have p1 h p2. Okay, so these things is always going to be common. And apart from them, obviously we have 21 guests. Okay, and three are together. So now we have 18 more people. Okay, so total we have this thing and then 18 more people. In total we have 19 people. Okay, because we have 21 people, but because three people are together, they're always together. So this means that they're sitting together. So they just count them as the one unit. Okay, okay. So this thing means that total 19% we have to arrange in the circle. So that is going to be n minus 1 factorial means 18 factorial. Okay. But out of P1 and P2, it may happen that P1 sit this side or P2 sit this side, or maybe P2 sit this side or P1 sit this side. So there can be mutual arrangement between P1 and P2 is 2. Means two number of arrangement can be there. Means P1 H P2 or maybe P2 H P1. Sometimes P1 can sit this side also, P1 can sit this side also. So 18 factorial into 2. So these are the total number of circular permutation. Like there are different bunch of useful formula for you, so I think I should explain this particular useful formula. So this particular useful formula is all about, let's say, like total number of ways selecting one or more items from group of n distinct item, it is 2 to the power n minus 1. So like let's say there are five element in set a b c d e f. Let's say you're forming a subset, six element, you're forming a subset. Okay, subset you are forming. So like while forming the subset, the main question is that what will be the total number of subset. So either this element can be present or not, either this element is present or not, this present or not present or not, present or not. So 2 to the power 6 is the total thing. We also discussed this thing in the set and set thing. Okay, and relation thing. Okay, so total number of ways a particular items can be selected, one or more items, means one or more items. But here you have to select either all items or none also. So that why we have to do the minus 1. So we have to do 2 to the power n minus 1. So 2 to the power n minus 1, either we select one or more item. And if you don't do minus 1, it means that we are selecting 0 or more items. Maybe if any one of them don't get selected, we are also having that part in 2 to the power n. So 2 to the power n minus 1 means either one or more, either one or more. And 2 to the power n means either 0 or more. Okay. And similarly, there are some different types of other formula. The number of ways of selecting r items out of n identical items. It's saying that let's say there are n identical item. N all items are same. Let's say n apple are there. N apple. All apples are same. Choosing r apple. Obviously, you can do it only one way. Choose any r apple. All are the same. Then total number of ways of selecting zero or more items at least zero or more item, means at least one item from uh, group of n identical items. It may happen that you choose one, may happen that you choose two, may happen that you choose three. The total number may don't choose any one. So total number of possible combinations is n plus one. Why? Because you either can choose any number of item. Na? Out of n plus one or twice, you can choose any number of item. Either you can choose zero or you can choose one or two or something like that. Okay. And the third particular result is total number of selection of some or all out of PQR items, of which P are alike of one kind, Q are alike of second kind, and rest are alike of third kind, is something like that. Let's say there are three elements. Okay. Like I'm explaining this formula because this formula is important. I don't know how to solve this question on that. Obviously, find some questions in the book R.D. Sharma, but this formula is the more important. Okay. It's saying that let's say there are P element of one kind, Q element of one kind, and rest all are the distinct element of R kind. Okay, and means obviously P element of one kind, Q element of one kind, and rest are of R kind. Total number of arrangement. Okay, so obviously out of P, one or more can be selected by P plus one ways. Okay, out of Q, Q plus one ways, and out of R, R plus one ways. And obviously do minus one because some items may not be selected at all. So obviously to avoid that particular part, you do minus one. Let's say you have PQR of some certain kind of element, and let's say there are n items of different kind, means all are distinct. Out of PQR means there are P element of same kind, there are Q element of same kind, there are R element of same kind. But apart from that, also you have N element of different kind also. So what you need to do? You need to do P plus one, Q plus one, R plus one into 2 to the power n minus one. So like this is just the fundamental of product rule. What of the product rule we saw? These are can be done by p plus 1 ways, done by q plus 1 ways, done by r plus 1 way. Obviously, distinct item is getting selected by 2 to the power n ways. So 2 to the power n ways, and do minus 1 to avoid not selection. So obviously, if there is no any selection, for that we avoid the minus 1 part. Okay, so there is a one more popular questions which is of the factor. Okay, the thing is that total number of factors of 2160. So obviously excluding one. Excluding one is one should not be counted as a factor. So what is a factor? If you do the prime factorization of 2160, you get 2 to the power 4, 3 to the power 5, 5 to the power 1. So total number of factor means all those numbers which actually divide 2160. Let's say 2 to the power 4, 3 to the power 3, and 5 to the power 1. Let's say you choose 2 into 3 into 5, it will be a number that is divide to 160. Let's say you choose what you can choose. Let's say you choose 2 to the power 2 into 3 into 5, it will also divide it. Let's say you choose 2 to the power 3 square into 5, it will also divide it. Let's say we 2 and something like that, it will also divide. Okay, so what are all the possible combinations? We can say that we out of 4 twos, out of 3 is 3, and out of 1 5, we have to choose them either one or more. Okay, so either one or more means this is something like p element of one kind, q element of third kind, second kind, and r element of third kind. So it is getting chosen by p plus 1, q plus 1 into r plus 1 minus 1. So obviously it will be 4 plus 1, 3 plus 1, 1 plus 1, minus 1. Why do you do minus 1? If you just don't do minus 1, it means that you are dividing it by 1. But obviously 1 we have not to include. Okay. So this will give you 39, which is the total number of factorial, total number of factors of 2160. Total number of factor of 150. Just do same thing. Do the factorial, this prime factorization, and whatever the power are there, just do the p plus 1, q plus 1, r plus 1 minus 1. This is the particular formula. One of the most popular questions actually. And the last section, which is called a de-arrangement thing. Obviously, there are a lot of questions in the de-arrangement from the your paper also. So, in the permutation combinations, let me discuss a de-arrangement, and then we can move ahead. Like in the Adit Sharma, you will also find a lot of topics related to equation solving in the permutation combination. You can skip that part, but obviously, whatever topics that I have touched, practice questions from that thing. Okay. So it is saying that n distinct objects are arranged in a row, then the number of ways in which they can be de-arranged so that none of them occupies its original place. Let's say this is the 1 2 3, and there are three person in the room. Everyone in the one is in the first room, was two in the second room, and the three is in the third room. And let's say we want to arrange so that none of them get to their original room. Let's say we keep three here, two here, and one here. So obviously one is the room A, but obviously now one is the room B. So this is not in the correct place. Three is in the room C, but now three is in the room A, not correct place. Two one was on three was in two was in the room B, but now two is in the room C, not correct. So de-arrangement means whatever the original order was, you are changing order such that all of the elements are actually being distributed in different location and not their original location. So this particular thing can be done by this particular way. It is represented by dn, means de-arrangement of n. It is the number n factorial 1 minus 1 factorial plus 1 upon 2 factorial 1 is 3 factorial, something like that. Okay. If we just see the examples, let's see the examples. The number of which 5 letters can be placed in 10 marked envelopes. Okay, there are 5 letters. Okay, 5 letters are there, and they are being placed in 10 marked envelopes. Means there are envelopes which are marked. There's something written, so that no letters is in the right place. So number of ways is doing equal to the number of rearrangement of 5 objects. Means 5 objects are there. We are trying to arrange so that none of them occupy to their original places. So it means that same formula: n factorial upon 1 minus 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial minus 1 upon 5 factorial means up to 1 upon n factorial, up to 1 upon n factorial. Just see, repeat the same thing, put the n. Simple question. If just it identified the dearrangement thing, just put the n, get the answer. But sometimes this particular things can be modified also. Let's say out of R objects occupy the places assigned to them, their original places, and none of them remaining A minus 1 R object occupies original places. Saying the total number of objects are R, N. Okay, and it's saying that R number of places out of them are actually occupying their original places. R number of places are occupying their original places. And N minus R should be dearranged. Means N minus R items should be arranged so that none of them occupies their original places. So what do you need to do? Just the same thing. Okay, choose r item out of n which are in the correct place, so ncr, and out of n minus r item, just repeat the same thing, n minus r times. Okay, the same thing. Okay, so either all are rearranged, or if some of them are rearranged also, choose n items, r items. Let's say out of 10, only 3 are rearranged. So 10 c7 means all the 7 items are not arranged, rearranged, and then 3 items. For 3 items, repeat the same formula up to 3. Okay, so you can also see this particular questions ki Ravi write a letter to his 5 friends and addresses their corresponding envelopes. The total number of ways in which letters can be placed in the envelope so that at least two of them are in the wrong envelope. So it can be done by what is. So obviously it is means two of them means that it may happen that three of them also can be there, four can also be there, five can also be there. At least two of them get the wrong address, or at least two of them. Maybe three can also get the wrong address. Four of them also get the wrong address. Five of them also get the wrong address. So it is just 5CR. But obviously it will do it 5C 5 minus r dr, and we choose obviously want to do it for 3 4 5 same. We need to apply the summation, solve the same part, and obviously just don't worry about the calculation. If you know what the formula is working, it's the done. Okay, so obviously just if you put r is equal to 2, it will be 5c3d2, means two letters are at the wrong address. If you do r is equal to 3, it means that 5c to d3, it means that 3 letter are at the wrong address, then d4, then d5, and something like that. Okay, so I discussed a lot of things in the permutation combinations. These questions you can practice, and apart from that, go to RD Sharma, and whatever the questions I have just topic I taught you, just practice the questions from that particular topics, and this particular permutation combination will be done for you. So these questions are enough. RD Sharma is enough. Obviously, just touch the topic questions from the topic that I taught you. Remember the formula, and you are actually solve the each and every question from that particular thing. Okay.